In this lesson, you will learn about the most crucial part of the LangChain framework, the chain itself and the components that comprise it. I'll introduce you to the LangChain execution language, then I'll show you how to create a simple chain using the LangChain execution language. In one of the earlier lessons, I introduced you to the generative AI application pipeline. As a generative AI application designer or developer, you will spend a majority of your time carrying out activities related to model interactions, model response post-processing, and developing application logic. At a high level, we may think of the code in these three boxes as the orchestration logic for the Gen AI application. The orchestration logic does multiple things. It formats the input. For example, it may convert the input to lowercase, or it may filter out the personally identifiable information in the input. It can invoke one or more LLMs, format the output. It may have the code to access data from other sources such as APIs, databases, or files. LangChain offers utility components that makes it easy to build the orchestration logic. The orchestration logic built with LangChain components is referred to as a chain. Let's dive deeper into the idea of a chain. This is the simplest form of a chain, combining the prompt template and the LLM class. The chain takes the input variables for the prompt template. It then generates the prompt using the template and then invokes the LLM. The output from the LLM becomes the final response from the chain. In this example, the chain consists of a prompt template and an LLM. However, a chain can also be composed of other chains. Here is another illustration of a compound chain, which is referred to as a sequential chain. The idea is that the output from chain 1 is passed as input to chain 2. Each chain may be composed of one or more chain components. For example, chain 1 and chain 2 may be simple chains created with a prompt template and an LLM. So key point to note is that chains may be composed of components, they may be composed of other chains, or a mix of chains and components. Here is a more formal definition of a chain. A chain is a workflow that connects various components like prompts, language models, and tools to perform a specific task. Each component in the chain passes its output as input to the next component. This modular approach simplifies the building of sophisticated and adaptable applications. Now you must be thinking, what is a component? A component is the smallest building block in a chain. Next, I'll go over the commonly used chain components. You've already learned about the LangChain prompt templates. The prompt template class takes a dictionary as input and outputs a prompt value. It is the text that is sent to the LLM as input or query. Chat model and LLM represents the large language model components. Only difference between the two is in their outputs. The output from the chat model consists of a list of chat messages, whereas the output from the LLM is a string. The output parser component is responsible for parsing the response received from the LLMs. There are multiple types of parsers that you will learn about in the section on handling structured responses. Retriever components are used for fetching relevant data for building RAG pipelines. These components take string as input and they generate list of documents as output. You will learn about the retrievers in the section on vectors and vector databases. Tool components are used for building generative AI applications that allow an LLM to access dynamic information such as stock tickers or city weather via tools. You will learn about these tool components in the section on Agentic RAG. All of these components are represented by LangChain classes that implement the runnable interface. This interface exposes common attributes and functions for all of these component classes. Interestingly, you've already tried the functions exposed by the runnable interface. In earlier lessons, in this section, you have tried the LLM invoke, batch, and streaming functions. Chains are created by stitching together these and other components using the LangChain execution language. LangChain execution language is a declarative way to compose an LLM pipeline, also known as the chain. Here is an example of a simple sequential chain created with LangChain execution language. The pipe character is placed between the components as an indicator for passing the output from one component as input to the next component. Let's take a look at a simple chain created with LangChain execution language. In this demo, I'll carry out 4 steps. I'll create a prompt template, then I will create an LLM, create a chain out of the prompt template and the LLM, and then we'll test the chain. I've already put together some boilerplate code, so let me just run this. This is importing the prompt template and the create Google LLM utility. So let's go ahead and create the prompt. The prompt that I'm going to create will ask the LLM to tell a joke on a given topic. Let's create the template out of it. Prompt template equal to prompt template, provide the template equal to tell joke template, and provide the input variables. So now that we have the prompt, let's just run it. So the prompt template is now created. Next, we'll create the LLM. To create the LLM, I'll simply use create Google LLM, and I'll set the API key prompt equal to true. So that means it is going to prompt us for the Google API key. So let me just run it, provide the Google API key, and now we're ready to create the chain. To create the chain, we will use the LangChain execution language. So I'll call this joke underscore chain equal to, this is where the chain component needs to be provided. So I'll provide the prompt template, copy and paste it, put a pipe character between the components, and then add the LLM here. Run it, and now we are ready to test the chain. To test the chain, use the chain name dot invoke and pass in the topic. I'll set the topic as, let's use the common one, chicken, and run it. So here is the joke that was created by the LLM. The demo code that I walked you through is available on the chains page under the section LangChain. Let me quickly give you an idea of what it has. Now you must be wondering, how is this pipe character working? So you will find that in this demo code, I'm talking about how the pipe character has been overridden by LangChain. You will learn more about it in later lessons, but my suggestion would be to read through this and understand the working of the LCL from the pipe character perspective. You will also find the code that I walked you through. Let's go over the key points from this lesson. Chains simplifies the development of LLM pipelines. There are multiple components that can be used for building chains. Chains can be composed of other chains, and such chains are referred to as compound chains. LangChain execution language is a declarative way to create chains. In the next lesson, we'll dive deeper into the use of LangChain execution language. Happy learning, and I'll see you in the next video.